Hello, I'm Christopher Travis, and this is our lesson on implicit differentiation. Yes, long words do have a negative connotation, but this lesson really isn't as bad as it may seem. Up until this point, we've only dealt with equations that were solved for y. Therefore, y was on one side of the equation and x was on the complete opposite side of the equation, so there wasn't really any issues taking the derivative. Let's take the derivative of this. This derivative can easily be taken by using the power rule. As you can see, there's no issues whatsoever in taking the derivative of this problem. Easy, right? Well, not always. If only life were that easy where y and x would always remain on opposite sides of the equal sign. However, it's not always that easy, and we have to deal with problems like that sometimes. This is where implicit differentiation comes in. When x and y seem to love each other so much that they just can't stay on the opposite side of that equal sign. It may look something like this. As you can see, the equation is not solved for y. In fact, x and y are both on the same side of the equal sign. Relax though, this isn't much different from taking the derivative of functions we're used to taking it from. Just make sure to take the derivative of everything on both sides of the equal sign. However, you have to incorporate this dy over dx when you take the derivative of y. For the sake of keeping this simple, we'll use the same example I used earlier in the video. So first, we have to take the derivative of x squared. Simple enough. Simple power rule, multiply 2 to the front of x, and then subtract 1 from the x squared, 2x, right? Now we take the derivative of y squared, where you do practically the same thing, but you must add one crucial thing. As you can see, we got 2y using the same basic principles using the power rule. However, dy dx comes in because that's the derivative of y, and that's what the equation will be set to towards the end of the problem. Now remember, we must take the derivative of everything on both sides of the equal sign, including that 25. The derivative of a constant is 0, so there's that. Now we have to isolate dy over dx. We'll start by subtracting 2x from both sides. There's that, and now we must divide both sides by 2y to isolate dy over dx. What we're left with is dy over dx equals negative 2x over 2y. But let's always remember to simplify. The 2's cancel out, and what we're left with is dy dx equals negative x over y. And there's that. Not bad, is it? In this problem, we have to find dy dx at a specific point, however. Of course, first we'll take the derivative of the entire function. And here we have 10y dy over dx equals 6x squared minus 5 dy dx. Now at this point comes a decision. You can either solve for dy dx first and then plug in, or you can plug in from the get-go. It's very subjective. It all depends on what you want to do. In this problem, we'll plug in right now. And then we simplify. Now the goal is to get dy dx on the same side of the equal sign. So we'll add plus 5 dy dx to both sides. And then we have 25 dy dx equals 6. And we'll divide 25 on both sides to get dy dx by itself. What you're left with is dy over dx equals 6 over 25.
Now let's try a couple practice problems. Find dy dx of the equation y squared minus 6y equals 5x. Try to solve it first on your own. Did you solve it? To find dy dx, first have to differentiate the problem. After differentiating the problem, you would end up with 2y dy dx minus 6 dy dx equals 5. Remember to use dy dx whenever you take the derivative of y. Next, you can factor out a dy dx to get it by itself. Remember, it is important to get dy dx separated. Now, the only thing left to do is divide 2y minus 6 from both sides. This will leave us with dy dx being equal to 5 over 2y minus 6. Do you feel more confident now? Let's try one last practice problem dealing with trig functions. Try it out and see how you do. Just like the last problem, start out by differentiating the equation. The derivative of sine is cos. And always remember to use the chain rule whenever you see a function inside of a function. You can multiply the 2's from negative 2 sine 2y and 2 dx to leave you with cos x minus 4 sine 2y dy dx equal to 0. Now we have to try to get dy dx by itself. To do this, we need to subtract the cosine x from both sides. To divide, you're done. The answer would be cosine x over -4 sine 2y. Congratulations, you successfully completed a lesson in implicit differentiation. I hope you feel more confident next time you see one of these problems. This video has been brought to you by Chris Travis and Diamond Kelley. Thanks for watching.